Hello everyone, myself Bharat Kumar M from Master Venkateshwar College of Engineering, and today I am here to do a seminar presentation on hybrid and electric vehicle technologies for off-road applications under the guidance of Professor Megavashini SK. These are the contents of today's agenda. That is the introduction, literature survey, methodology, results, applications, conclusion, and reference. Coming to the introduction part, the development of automobiles powered by internal combustion engines was one of the greatest engineering achievements towards the end of the 19th century. However, vehicles propelled by however, uh, heat engines are very poor in fuel efficiency. Besides the combustion of hydrocarbon fuels in these vehicles release many toxic gases. Hence, the major challenges automobile sector needs to address today are how to reduce impacts of climate change and how to lower dependency on oil fuel or the fossil fuels. Several strategies are being considered for addressing these issues. These include switching over to eco-friendly biofuels, improved engine design, and use of electric vehicles. However, electric vehicles and hybrid electric vehicles hold the promise of reducing carbon emissions from transport sector significantly by efficiently making use of the batteries and an electric motor in electric vehicles and a combination of internal combustion engines with a fuel tank, a motor, and a battery vacuum. Hybrid vehicles, the uh, pro- uh, we can reduce the fuel efficient fuel. These are the literature surveys which I have referred. And coming to the methodology part, the above figure shows the system level architecture of a batteryless hybrid off-road vehicular system, in which in heavy vehicular off-road applications such as mining and construction, solely using the IC engine system will lead to a large transmission system to meet the torque and power demand. This high torque and power demand can, however, also be obtained through electrification, that is, by using an IC engine that can drive an electric generator. The generator running at variable speed, that is due to variable IC engine, leads to a voltage system with variable AC voltage amplitude and frequency. This variable voltage or frequency is then converted to a constant DC voltage by using a rectifier or regulator. The constant DC voltage can then be transformed into a controlled three-phase AC system. The amplitude, frequency, and phase, and these three-phase system can be controlled by using a power electronic system, that is by using a rectifier. The three-phase by using a inverter. The three-phase power thus obtained is used to drive an electric motor to drive the vehicular load. The load that is to be driven. And this figure shows the system level architecture of an hybrid off-road vehicular system with an ultra capacitor for storage. Mainly the difference between the above figure and this figure is that an ultra capacitor and a controller is added is added here because during the braking of vehicle or braking of some of its movable parts, mechanical energy can be transformed into electrical energy and stored in the ultra capacitor. May be noted that an ultra capacitor has high specific power and can support sudden power transient input for short duration. The stored energy can then be used to accelerate the vehicle at a later time. In this way, regenerative braking can be facilitated and energy can be saved and better fuel economy can be achieved. In this case, a coordinated switching mechanism will be needed to select between the ultra capacitor and the alternator or rectifier. During the braking cycle, the controller coordinates appropriately by commanding the ultra capacitor, inverter, and alternator or rectifier to channelize energy flow from the motor into the ultra capacitor. And this figure shows the architecture of a compound hybrid excavator in which an engine drives the generator and produces a three-phase AC voltage, and that voltage is then converted into a DC voltage by using a PWM converter, and converted DC voltage is then leveled up by using a DC-DC converter, and then the produced three-phase AC through the generator is given to the hydraulic pump in order to uh, control the gear, the right wheel and the left wheel, and then the converted DC voltage is given to the inverter in order to control the swing mechanism of the hybrid excavator. And coming to the result part, in a regenerative mode of operation, it is possible to recover energy from the mechanical loads in this compound architecture, primarily during the swing operation. It is possible to recover energy from other moving members, such as boom, arm, and bucket, which are hydraulically operated with appropriate bidirectional control by fluids. And below figure shows the figure shows the movement of the hybrid excavator, upper movement and the lower movement, and power generation motor and electric motor for the tunable of the upper structure. And the inverter is used in order to coordinate between these two. And then the load duty cycle and the torque of the off-road applications varies with that of an regular vehicles, and their load duty cycle and torque requirements is as shown in the figure. And the hybrid excavator load demand bow figure shows that when excavator is performing an heavy digging or a light smoothing, load duty cycles, and right side figure shows the torque demand curve that is required, that is used in an hybrid excavator. And the applications involve excavators, bulldozers, mining vehicles, and agriculture. And coming to the conclusion part, while the hybrid electric vehicles or the electric vehicle technology has established its place in regular passenger and commercial vehicles in the area of off-highway or off-road vehicular systems, it is still not at the same level compared with regular vehicles. The reason for this are the number of vehicles involved, cost, fuel economy, load duty cycles, governmental regulations, and the number of populations in the society influenced by the incorporation of relatively new technology. The adoption of the technology will also depend significantly on the level of development in energy storage and power generation technologies. Thus, it can be said that the application of hybrid and electric vehicular technology to off-road vehicles will most likely be an evolving and open-ended process, at least for the time being. And these are the references which I have referred. And thank you.